In this lesson, we're going to take a look at exponents and writing exponents, evaluating exponents, and writing exponents as a product of factors. Right. The first thing we need to understand is a little bit of vocabulary with exponents. And an exponent is a number that tells us to multiply repeated times. So what you'll see when you see a number written in exponential form, as it's called, for example, in 2 to the 4th power, we read that 2 to the 4th power. What that tells us, first of all, the big number is called our base number. That's our base. That tells us what number we're multiplying. We're multiplying the number 2. The smaller number in the upper right-hand corner tells us it's called the exponent, and that tells us how many times to multiply. In this case, we're multiplying the number 2 4 times. Not 2 times 4, that's the common misunderstanding, is 2 to the 4th equals 8. And we'll look at that in a bit as why that is not 8. It's actually 16. All right, so the base number tells us what number we're multiplying. The exponent tells us how many times to multiply. Just a couple other language things here before we get into some examples. The common term you'll see for the to the power of 2. All right, if I have a number 5 to the power of 2, the common math term we use, which we'll talk about in a future lessons, is to say it's squared. And we'll talk about that later. Another common term that you'll see is anything to the power of 3 is called cubed. So instead of saying 4 to the power of 3, in this example, we'd say 4 cubed. Once you get higher than an exponent higher than 3, then we just say to the power of. So for example, 2 to the power of 4, going back to our original example. The first thing we have to understand is what an exponent actually tells us. And to do that, we're going to write exponents out as multiplication problems. All right. The directions you'll often see is write it as a product of the same factor. Remember, product means answer when you multiply, all right, of the same factor. The base number is always our factor. So for example, this number, 7 to the power of 2, or 7 squared, as you'll often hear it, means take the number 7, because that's our base number, and multiply it 2 times. So we have 1 7, 2 7s. There is our 7 to the power of 2. All right, and if we multiply that out, 7 times 7 is 49. Next one tells us 5 to the power of 7. What is 5 to the power of 7? Again, before we even worry about an answer, we need to write it as a product of the same factor. Our factor, our base number, is 5. So that's the number we're multiplying. Every problem will be 5. Then I can take my exponent to find out how many times to do it. I need to multiply the number 5 7 times. So there's my first 5. There's my second, my third, my fourth, my fifth, my sixth, and my seventh. Now that answer is going to get very large, probably a calculator problem, but you can see it's 5 multiplied out 7 times. 5 times 5 times 5 times 5 times 5 times 5 times 5. That is 5 to the power of 7 written as a product of the same factor. Let's look at a couple more examples of this just to make sure we understand the language. Here again is 10 squared. What does squared mean? Squared means to the power of 2. So what I really have is 10 to the power of 2. And when I write that as a product of the same factor, I have 10 times 10. 8 cubed. Remember, the phrase cubed means the exponent is 3, or to the power of 3. So 8 cubed means this. And when I write that out as a product of the same factor, it means the number 8 3 times. So that's writing problems, exponents as products of the same factor. Write out what is the multiplication problem going to be to find the answer. All right. You don't even, you'll see in the first example, I did just to get kind of get the point across, I did even find the answer, but you don't necessarily even have to. That's going to be the next step. When you're asked to write a power as the product of the same factor, what you really are looking for is what multiplication problem does that exponent mean to do? We can go the opposite direction. All right. Here, we took an exponent and we wrote it as a product of the same factor. Now, we're going to take a long multiplication problem and we're going to write it in what's called exponential form. Or in other words, we're going to write this math problem using exponents. Okay, so if I look at my first highlighted example here, you can see that I'm multiplying the number 2. So I have a base number of 2. The question is, how many times am I multiplying it? Well, I'm multiplying it once, twice, 3 times, 4 times, 5, 6, and 7. So I have 7 2's. So my exponential form is 2 to the power of 7. Right? Here's an example that's a little more interesting because you can see there are 2 bases, and you'll see some of this. All right, so this time we have 2 bases. We have a base of 4, and we have a base of 3. Let's start with the 4. We have 1 4 and 2 4's. So I have 4 to the power of 2. Then, if I look at my 3's, I have 1, 2, 3, 4, 5 3's. So I have 4 to the power of 2 and 3 to the power of 5. And because, as you can see, these are all multiplication problems, I have to take those 2 exponents, those 2 numbers, whatever their answers may be, and multiply them times each other. So when you have 2 different bases and you're asked to write the product of primes out in exponential form, you will find both exponents and then multiply those 2 exponents times each other. The last step we have to look at is putting this all together and actually evaluating an exponent. And what it means to evaluate is to find the value. All right, it's a fancy way of saying answer the question. So if what we're really going to do to evaluate, we're going to go back to our products of the same factor, and this time we're actually going to answer. All right, so to evaluate means to find the final answer. Here's an example. Evaluate these expressions. We have 4 to the power of 3. Well, I have to start with the product of the same factor. I have to look at what does 4 to the power of 3 mean. Again, this is not 12. We have to kind of retrain our brains. This is not 4 times 3 is 12. This is 1 4 times a second 4 times a third 4. Now, because it says evaluate, I need to actually do the multiplication step. 4 times 4 is 16. And then bring this one, 16 times 4. I'll do that to the side here. 6 times 4 is 24. 1 times 4 is 4, plus the 2 is 6. So I have 64. 4 to the power of 3 is 64. Notice much higher than that 12 we talked about before. When things go exponentially, they get large. You'll get large numbers very quickly. 7 squared is our next one, and remember, squared means to the power of 2. So I have 7 to the power of 2. Well, that means I need a base number of 7 2 times. And that one we can do. 7 times 7 is 49. So 7 squared is 49. Last example of this we'll look at is 5 to the 4th power. 5 to the 4th power, I'm going to first write it in exponential form so I can see what it looks like. And now I'm going to write it out as a multiplication problem. I have a 5 4 times. Okay, the base number 5 multiplied 4 times. And once again, I have to work it out this time. So 5 times 5 is 25 times this 5. All right, so I'll come over and I'll do 25 times 5. 2 times 5 is 10, plus 2 is 12. So right now, my answer is 125. But I'm still not quite done yet, because I still have one last 5. So now I'll take 125 times 5. And I do 5 times 5 is 25. 2 times 5 is 10, plus the 2 is 12. And 5 times 1 is 5, plus the 1 is 6. So I should have 625 when I'm all said and done. I've multiplied that 5 4 times, is 625. 5 to the 4th power is 625. All right. The last thing that you may be asked to do is take a series of exponents and put them in order from least to greatest. And this will take some time because what you're ultimately doing is taking 4 different numbers and evaluating them all. So I'm going to have, if I do this highlighted example here, I've got to find out what 4 to the power of 3 is, what 1 to the power of 13 is, what 12 to the power of 2 is, and 8 to the power of 3. And I need to evaluate each problem. So let's start with my 4 to the power of 3. That would be 4 times 4 times 4. And I have 4 times 4 is 16. And I think we said earlier, 16 times 4 is 64. So 4 to the power of 3 is 64. Now I'll do my 1 to the power of 13. And that one's kind of nice because seven. I believe that's 13 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13 ones. Now that looks like a lot. 1 times 1 times 1 times 1 is just going to keep giving you 1. So our answer here would just simply be 1. A lot of writing, not too bad on the math though. All right. Now we'll say 12 to the power of 2 is 12 times 12. And that's going to give you 144. You'll get quickly, or you start to pick up on some of the square numbers, which we'll talk about in future lessons as well. And the last one we have to figure out is 8 to the power of 3. So I have to do 8 times 8 times 8, or 3 eighths. And I know 8 times 8 is 64, but I need to do 64 times 8 yet. So let's check that out. 4 times 8 is 32. 6 times 8 is 48, plus 3 is 51. So this number is 512. Now, finally, I can actually put them in order from least to greatest. And it looks like we're going least to greatest here. It looks like my smallest is 1 to the 13th, obviously, because that's just 1. Then I have 64, which is 4 to the power of 3. Next, so I've used 1. I've used 64. It looks like next is 144. So, and that one was 12 to the power of 2. And then finally, my big answer, 512, is 8 to the power of 3. So here is those 4 exponents in order from least to greatest. Right. Same process, just have to do it a few times before you can then put the numbers in order from least to greatest. So just to summarize again, the most important thing is, as we look back, yes, you need to be able to take an exponent, write it as a product of the same factor, or take a long multiplication problem and write it in exponential form. The big piece, the most important thing to remember is what exponents mean. So your base number is the number that gets multiplied over and over and over. The exponent that never gets multiplied, it tells you how many times to do the multiplication problem. So 2 to the power of 4 is 2 times 2 times 2 times 2. All right. That is your summary of using exponents.